Can you guys see the screen?
Yeah.
All right. You mind just reading the chat, Lauren, in case someone has questions, because I can't see it.
Yep, I'm all good.
All right.
Okay, so while you're preparing this, I'm just going to preface this by saying that when we're doing recursive functions, right, we always have two main parts, right? We have a base case and the recursive call, and it allows us to essentially call a function multiple times, right? And because of this, it's an effective way to loop through digits, right? Like this problem over here. And we're going to be using the modulus and the division to kind of get through different parts of the numbers. So the two things that are really going to help us here is when we are dealing with integers, right? When we do division, if we were to divide something by 10, what that essentially does is because integers can't hold decimals, it kind of chops off that last digit. So if we had the number 123, right, we know that technically 123 divided by 10 is supposed to be 12.3 because it's an integer, it can't hold that 0.3. So the 0.3 gets deleted essentially, and we're left with just the 12. So dividing an integer by 10 is a very effective way to chop off the last digit. And this is great if you wanted to loop through different parts of the digit. Now, if we wanted to extract the last digit, we would use something similar. We would use that number modded by 10, and this would be what would give us that last digit. So in the 123 example, mod that by 10, and you'd get the 3. So using these two ways, we're going to likely be using them for this digit match question as well as other digits. So I just wanted to start by saying that. Okay, you can go ahead.
Yeah. Excuse me. So this prints out 1. Saying to be matched in the prints to I'm confused with this output here. It says it prints 1, but
It returns the number of positions where their digits match. So in the case of,
for all 3 of them or just 2 of them? Because they match in 6 and 7, but oh no, I'm sorry. I don't know why I did not see 6 here. Yeah, never
yeah,
mind.
yeah, you got it. So you're trying
So the
to
number of
match three.
positions that they match there. Yeah. All right. I don't know if people are active, but I think the whole point of review sessions is to ask questions from the audience as well. So I don't want to just do the problem. I want people to also help me out.
All
So
right.
given that this returns 1, our what will be the argument, or I guess like the data type we're going to be putting here? So I know this is going to be just digits match, right? What's it called? Yeah, digits match. And I'm talking about this very first data type here, right? I mean, here it says prints 1, but that's because this is C out this. So can somebody tell me what data type I'm going to be putting there? I just want to make sure people are active. So it's not just a silent session.
Int.
Yeah, an integer. Yeah, great. So here we have 3 parameters. So it's already given what these parameters are. So they're integers. So I'll call them int A, int B, and C. All right, cool. So when it comes to recursion, It's recursive because the function calls itself, right? So I'm going to return something for now. I'm just going to return 0 just because I know it's going to return an integer. So we're going to be comparing positions across each of the digits. So what I'm doing actually is returning some sort of counter, right? So I want to go through each individual value, right? So for example, if I have 168, 567, just actually copy these here so I'm not going to refer back to it. Okay. I'm checking what positions they match, right? So I can think of it as looking at 1 equals to 5 equals to 7. And if these are all equal, then I should increment it somehow, right? But that's not the case here. So I just skip that. So I go to the next one. And so this is true, right? So I'll increment whatever counter I have, and I'll keep doing this until the very end. So equals 7 equals 7, and so I don't do anything, which is why it returns 1, right? So with that being said, as I recurse down, right, I'm going to need to call this again so that it actually checks the next digits, right after the first one. So it's not like I'm applying this function to each individual parameter. It's happening to all three of them simultaneously, right? So if I'm returning this function again, right, because that's what recursion is inherently, how might I return um, the next incoming digits? Like, for example, how would I just remove 168, 567? I'm sorry, how would I remove 1 from 168, 5 from 67, and 7 from 67? So, like, I want my result to take in this. So, let's say the function is just f. I want to write digits matched, right? So, I do this.
Kevin, I think
Yeah.
it might be easier to do it the reverse. For instance, you work from the right
Hmm.
to the left
Okay,
because
sure.
if
We can do that. Yeah.
yeah, if we do it
Ultimately, order does not matter. Yeah.
because this kind of relates to what I was saying before, right? We can start by taking that last digit, right?
Mm-hmm.
We can do that by
Yeah.
modding it by 10
Oh, yeah,
and
for sure.
then
Yeah.
yeah, and kind of look at that one digit by one digit.
Yeah.
Because I think if we went
I was
from
thinking
left,
about it like heuristically at first, but now, yeah, from the programming perspective, that makes sense. So yeah. So instead of doing that, when we call this function, we want this to look at. Yeah, I guess it's true. Yeah, because there's an operation you can do more easily, right? So let's reduce this to 1 6 5 6 7 6. So my question to you guys is, how can I get this? What could I do to reduce this to the next set of digits?
Divide
Remember,
by
this
10.
operation's, yeah, dividing by 10, exactly. So at some point in this function, I will be dividing by 10. That's good.
and what we
And
can do is with
yeah.
recursion, right? We're able to actually put in the parameters with that division by 10 applied to them. So each time that this function calls itself again, right? Because that's what we do with recursion, it calls it with the parameters divided by 10, so missing one of those digits, right? The rightmost digit. So it's as if you have a call inside another call inside another call. So the first time that you
Mhm.
call it, it'll be 168. Then it'll only be
Yeah.
16. Then it'll be 1, and then you return counter.
Yeah. So the reason that this works is because you're dealing with integers and not double or decimal values. So integers are strictly discrete values. So if I were to divide, let's say 767 by 10, I would get 76.7, right? But since I'm dealing with integers, it just rounds it down all the way. So this will just be equal to 76. Of course, I just wrote this down here. This is meaningless right now because, this is just sitting here without any other supporting lines of code, but we just wrote it down here because this is going to happen. This is what we want to do. So the next step here would be to do the comparisons, right? So this is only happening once we have compared the last digit, right? So 8, 7, and 7 here. So if I wanted to compare the last digit, how can I access it? How can I access 8, 7, and 7? What would I do? Of course, I would need to declare an integer of some sort. Let's call it a last equals and then a something, right? So how would I get that last digit?
You do the percentage thing?
The percentage, right? And that's the modulus operation. Yeah,
that one.
yeah. So just to remind you guys what modulus does, and that's correct. If I were to do, let's say 15 mod. Oh, but let me ask you this though. Modulus what?
10.
And which one? Why? Modulus 10. Yes, it's modulus 10. Yes, correct. Actually, I'm thinking right now, is it? Yeah, it is. Because the modulus something higher would give me the last two digits. Yeah. So yeah, modulus 10. And I was getting confused with something else. All right, so 15 mod 10 is equal to 5. Reason for this is because the modulus divides this number by 10 and then gets the remainder, which will be 5, right? But to avoid all the mathematical thinking and, all of the operations that are going on here in the arithmetic, what you can just think of it directly is if you have mod 10 or some power of 10, it basically just gets you that last digit. Depending on how many zeros you have here or how large the number is. So for example, if it's 15 mod 10, you're only going to get the last digit. But if it was like, for example, 155 mod 100, then you would get 55. And if it were 100, let's say 1,550 mod 1,000, then you get 550. So this is basically an operation that you should keep in mind when it comes to powers of tens, right? So that it just gives you that many digits relative to the power of 10. So in this case, we do 10 because we want the last digit, right? It gives us a single digit. So a last would be a mod 10, and the same thing applies to everything else, right? So b mod 10 int c last equals c mod 10. Okay, cool. Now we got this out of the way. Let me just get that out of the way now for now. Okay, so now we have all these last digits, right? And now we want to make the comparison. So we want to do that comparison. So let's say in this case, we have 8, 7, 7, right? So if we have that the comparison is true, well, we want to increment a value, right? We're incrementing some counter to decide how many digits have agreed, how many positions we've agreed, right? So in this case, we're going to have to check if a last equals to b last, and it's double equals for checking equality if it's a single equals assignment. Sorry. And we do c last. So if this is the case, what I would like to do is to increment. So incrementing a recursion is a little tricky. So you might think to do this, to initialize a counter. Let's put this at the beginning, right? But the problem with this is that you're calling this function recursively, right? So that means you're going to make this assignment after every call that you make, right? So your counter will be assigned to 0. So instead, what you would like to do is first establish a base case. It's something we should have done at the beginning. So the base case is what, results in the recursion to come to an end, right? So it'll come to an end once the number of digits is once we have a single digit left, right? Because we don't want to continue after that point. So if I wanted to check if there was a single digit left, let's do this.
We
So
probably
if
need a base case that says if you're at like less than 10, right? To say that you're on your last digit.
right.
So
So
if
this will be the case for each
yeah.
individual integer, right? So if A is less than 10 and B is less than 10
Actually, they're all
and
technically the
C,
same length, and because every time that we're incrementing them,
right? So we can just have to check one then.
yeah. So yeah, the only reason that we're able to do this is because again, they're all the same length. So because
Yeah.
we're incrementing all of them at the same time, there's no need to worry about that.
Yeah, sorry. I just paused myself for a little bit because I realized that we're gonna have to do this check again. Because if A is less than 10, we don't just simply stop because we still have to check if it's equal to all the other digits so that we can increment it,
I would
right?
say if A is less than 1, honestly, to show that we have 0 there.
Not 1. Well, actually, yeah, you're correct. Because if it's less than 1, then we can stop immediately because all the checks have been done here, right? Because if it's less than 1, that implies that we've divided it to the point where they're all 0.
Exactly.
And
So if we
yeah,
had
and
like
once they're all 0, you shouldn't check them. Because technically, if they're all 0, then they're all the same, and then you increment it. But in this case, we're only concerned for the first 3 digits we began with. So yeah. All right. So yeah, if it's less than 0, less than 1, sorry, then we return I
our
guess
counter, right?
we return 0. Because we don't return a counter. The counter will be done like this. I'll show you. So we return digits matched plus 1. If this is the case, right? Otherwise, we will just return this without the plus 1. So let me explain. So here, let me just make this a little bigger to see. Yeah. Let me just get rid of that counter. The counter was an example for why we shouldn't have that. Okay, so if A, so this is our base case. So if A is less than 1, this means that once we've exhausted all the digits, we return 0. And the reason we return 0 is because once we have A equals 0, B equals 0, and C equals 0, right? That's going to happen because you're applying this function to all the parameters, or sorry, applying this operation here to each argument simultaneously, right? So they're all going to be 0. They're all going to have the same number of digits. So once this is the case, we're not going to do anything with this. We're just going to return 0, right? Because we're done. Otherwise, if it's not, then we will check if they're all equal. And if this is the case, if they're all equal, then we will add 1 to digits matched. And we're returning an integer, right? So let's see what happens if we were to do an example here. So if I were to call ABC, right? I'll check if, of course, they're all 0s. If that's not the case, then I will just actually let me see. Because here they're all positive integers is what it's saying. So this is good. Okay, so then at this point we will do a recursive call, and then these parameters get smaller, right? So let's pretend that it actually manages to check this correctly. So this would be A divide 10, B divide 10, C divide 10, right? And then we add 1. And then we call this again. And let's say it matches again, right? So this would be F, I'll just copy and paste this, right? And then plus 1, right? So it's going to add 1 to this, right? When we find that it matched the number of digits, right? Sorry, it matched at a position, right? And it matches at a position again here. And let's say it reaches the base case, right? So this would be 0 plus 1 plus 1, which is equal to 2, right? So this is once every single one of these digits here have been exhausted, which means we've used them all and they've all been driven down to 0. And here with these ones, this shows that they matched at a position, right? So to actually show that this works, before I move on, actually, does that make sense to everybody? I can explain this again. And also it's important to know how to do like counts, or I guess like enumerating things in recursion, because enumerating in recursions are quite tricky at times.
Would you go one more time over
Yeah.
it? Like just brief, actually.
Sorry, over what exactly?
Yeah, go over it. Like, I mean, one more time.
Okay, sure.
Thank you.
Yeah, no problem. Okay, so first step is we check if our digits, so I'll actually write them down. So let's say I'll just give test examples. So I'll just do 1, 2, let's do 2, 2, and then 4, 2, right? So we'll check if these digits are of size less than 1, right? Which means, or rather that A itself is 0, right? So here they're all positive, so we're good. Otherwise, we will return 0. So here we'll get the last digits. So in this case, we'll get 2, 2, and 2, right? So here we'll check if the last digits are all the same, right? And since that's the case, since we have 2 is equal to 2 equals to 2, right? Then I will return digits matched plus 1, right? So that means in the output, right, I found a position that matched, and so I'm adding 1 to signify that. And upon the next run, right, in the next call of this function, the next values that I will have are 1, 2, and 4, because I have eliminated the last digit. So I will do this checkup here. This is not going to be true. So then I get the last digit. These are the last digits, right? And then I go here, the digits matched, because this is only going to return if they're all equal. They're not equal, right? 1, 2, 4, right? They're not the same numbers. Okay, so I go here, I return 1, 2, and 4. And this is going to be 1 divide 10, and 2 divide 10, and 4 divide 10. So this is going to be 0, 0, 0. And once I get here, this is going to return 0. So that means at the very end, the function will return 0 plus 1, right? So whenever you make a recursive call, and you have some operation on the outside, that operation is going to propagate up the recursion, right? So in the recursion, we go as far down as possible, right? So at some recursion, let's say do A, B, C, as I mentioned before, right? And as we saw before, this is going to be A divide 10, B divide 10, and C divide 10, right? And if it's the case where all the digits match, then I add 1. Otherwise, I'll do 0, but in this case, we'll say it's 1. And then I'll do the exact same call on this, right? So it'll do the division again. So it'll be A divide 10, B divide 10, C divide 10. And assuming that it did match, then we add 1. And the one that I had out here will remain, right? So this one is from this call, and then the next one is from this outer call here, right? So I'll keep doing this so long as I have digits that are greater than 1. And at the very end, it'll come down to 0 once it exhausts all the digits. So now I actually want to show what the output will be if I run this. So let's put this in the main. This is the C out, digits match. Oops. Why is it not going up? Trying to go up. Whatever. There we go. All right, let's do the same numbers we had here. So 1, 6, 8, 5, 6, 7. Okay. Okay. Why is it outputting 0? Hmm. See. We just test it with a single digit here. Let's do 8, 8, 8. Interesting. So it's not testing this correctly. Let's see why. A less than 1 returns 0. A last, B last, C last. Return this, else return that. I'll debug this real quick. So let's see, C out. Yes. Oh, so it's not even running this then. Interesting. I'm curious, what is A last? B last. And what is C last? Okay, so it's getting those digits correctly. When it comes to this, A last equals to B last. It's not, for some reason, it's not actually getting this. Let me try doing and A last. Maybe I can do that.
What about where they were declared in the main function?
Oh, there we go.
Oh,
That's strange. So I guess you can't do a transitive equals unless I'm doing it wrong. I don't know. So A last equals to B last equals to C last. For some reason that. Okay, so I have to do this then. Strange. Whatever. So I guess by transitive I mean like if this is equal to this, then this is equal to that. But I guess this is another way of interpreting it. I guess A equals B, A equals C. So yeah. Were you gonna say Lauren? Sorry. Lauren.
No, never mind. You're fine.
Okay. Now let's just do the outputs. Now this should work now. Sorry about that. That was strange. All right. Let me run this. There we go. 1. All right. So let's do another test. This one prints 2. Yeah. Oops. Yeah, there we go. So this is the code here. If you guys want, you can take a screenshot of that. So I'll just add some comments. And Lauren, do you want to go over the next question?
Sure
It's like
thing.
preface it. Yeah. Well, okay, I can go over the next one, but I just want you to preface it.
Yeah, no, I'm just taking a look
Yeah.
at the second one, or just really in general, because like there's
Yeah.
32 pages of questions. I'm trying to see like what would be a good
Yeah.
next one to do. I don't know. Which one do you think would be a good one to go over for the next one?
Let's see.
Because a lot of these seem to have like that same strategy.
Yeah, the same theme.
Yeah, I'm trying to find like a different one that could
Yeah.
work.
Well, we can quickly go over number 2, just to
Yeah, sure.
review checking even or odd. Let's see. Next one, swap first. Used to swap the first digits of positive 2 numbers that have the same number. It's a swap. 2, 4, 3, 3, 5, 7. 3, 4, 2, 5. The swaps to. Okay, that one doesn't seem too bad. It's just swapping isn't. It's a lot of fun. All right, number 2.
All right, question 2 then we're gonna do?
Yeah.
All right, cool. So question 2 is saying write a recursive function called digits opposite. The function has 2 integer parameters x and y that are positive and have the same number of digits. It returns the number of positions where one number has an even digit and the other has an odd one. So for example, if the function was applied to 17345 and 97813, it would return 2 because the third digits are 3 and 8, and the fourth ones are 4 and 1. In both cases, one of these is even and the other is odd. Okay, so very similar to the last one, right? We kind of want to have a counter here that kind of counts how many times that we have an example in which the position has one odd and one even. So we can test that by saying, unlike last time when we were just trying to see if it was the same digit, right? If the A's digit was equal to B's digit, which was equal to C's digit, this time all that we're seeing is if A's digit is positive, sorry, not positive, is even, then the B's digit has to be odd, or vice versa. If A's is odd, B's is even. And does anyone know how we can figure out if a number is even or odd?
Excuse me. Hmm.
Anyone know? Figuring out if a number is even or odd? Okay, we could use the modulus, right? So in the last problem, we used divided by 10, right? And that kind of essentially gave us what that last digit would be. Because, if you divide a number by 10, you're kind of just like taking off that last digit, right? Well, if you're exactly in the chat, a mod 2 equals 0 would be even. Why is that? Because we're seeing if a number goes into 2. Because if there is no remainder, which is what it's saying, right? If a mod 2 is 0, that means a goes evenly into 2, so it's even. So we can use if a mod 2 is equal to 0, we know it's even. And all we need to do to switch that to test if it's odd is say if a mod 2 explanation mark before the equal sign, right? Instead of having 2 equal signs, you would have an explanation mark and then an equal sign to say it's not true. Or you could say if it's equal to 1. Both of them works, right? Because if it has a remainder of 1, then we also know that it's odd. So both are ways to kind of say if it's odd, and then we can use both the odd test and the even test when we loop through each of the digits, just like our algorithm last time, and go from there.
Yeah. This one's a very similar structure, except now we're taking 2 parameters. This is B digits opposite. And A and B. So the base case will just keep the same. Because if I were to do this base case, I'm exhausting all the digits, right? Because this basically tells me that I've gone through everything already. I only need to check one of them because the sizes are going to be decreasing at the same time. Okay. Next one is to I guess we'll actually copy this as well. Right. Because
Yeah,
we're going to
so
be looking at the last digits.
yeah, one of the easier ways of doing this, like, I mean, more straightforward at least, is just kind of going from the last digit and kind of breaking it down, go digit by digit by digit.
Yeah. So now for the condition, so I'm just going to do this if all that else, right? So here I would like to check if my condition is met, right? And the condition is that I have one that's odd and one that's even. So here, this is the last digit. So let's call it AL is odd and BL is even, right? So that's one case. And the other case is or AL is even and BL is odd, right? So if I were to translate this into code, what would this look like? You can just type it in the chat. And this is just for this conditional I'm going to put there.
So we're saying the code for saying if A last is odd and B last is even, or A last is even and B last is odd. So does anyone have an idea on how we can write this in code?
Specifically in C++.
Well, that's the language we're learning, so yeah.
Any responses in the chat?
Nope. Okay. I'm here because I'm lost. So okay, yeah, let's go through it one by one. Okay.
Okay.
Yeah. So what we can do is
So
can say
yeah.
A last is odd. To test if it's odd, right? I can say if A last mod 2 is not equal to 0, that means I know that A last does not go into 2 evenly. So that means it's not even. Similarly, if A last is odd, I need B last to be even. So I'm going to have the two and symbols to show that it has to be both conditions needing to be true. And I'll do the same thing for B last, but this time instead of not equals to 0, it's going to be equals to 0. And the other part, right, will be identical. And we'll separate these two cases with the two vertical bars to show that it's going to be or. So quite literally what we wrote in that comment there, we're just kind of translating to code. Yeah, exactly what you wrote in the chat, Andres. Perfect job. Okay. Yeah, so for this, we're going to make sure that we're testing both conditions because either one is right. It just has to be that A last is odd and B last is even, or A last is even and B last is odd. As long as one is even and one is odd, it's totally fine. And like last time, we would kind of just add one to our return count if that is true. Otherwise, we just would return like last time. So just like last time, in the code, Kevin is doing the same thing, right? Each time we do the call, it's going to kind of chop off a digit, and it's going to do that to both A and to B. And we only add the one for when that condition is met. Any questions on this?
Not from me.
I'm just writing some comments down here in case you guys are ever going to take the pictures of this. So yeah, and then here, this is just going to be the case where otherwise
All of this is being
checking.
recorded, by the way, so you guys can all
Yeah.
access this later, and we'll also show you where to access this at the end too.
Checking. All right. Let's test this. We have two cases. We have this one. Wait, yeah, this is it. And we have the next one right underneath. Just this. Just to clarify. Checking even, checking if an integer is even. Compute
Yes, so there will definitely be similar questions on test 2
a
and the
mod
final.
2.
Recursion is one of those topics that I can guarantee will be on the exam. Well, I can't really pinpoint, exactly the type of question that he'll ask because, it's like there's 30 pages worth of questions. You probably can see that there's like a pattern here, right? In the sense that like we know the base way of doing this. We know that we create our base case, we know where we create our recursive case, right? Um, and essentially we just keep going through it. It's kind of almost like a way we do loops, right? In the sense that we find a way to recurse this. So I would recommend, like, for studying for this, because I know it can be difficult, right? Like, how do I know what to do for this? Just keep trying practice questions like this, right? We know it's the same algorithm, it's just the test condition for this is different. If you're having a digit question, usually you're going to end up using something with the modulus and division, right? So you want to just know, division, I can chop off digits. Modulus, I can like extract or read the digits. And if you know that, then honestly, like you can pretty much tackle anything else because the difference for this, finding if it was even or odd, like this is something that you probably would have done already for exam 1. So, like that part, you're just kind of bringing it full circle with doing your recursive. So that's how I would recommend kind of going about these questions.
I wrote down some notes right here, but I'll just explain it again. So if we do a mod 2 equals 0, because that means that the number is divisible by 2. And every even number is some number, let's say a times 2, right? You can write any even number as a product of 2 and something else, right? So it's divisible by 2. Otherwise, if it's odd, that means you can't do that, right? So this means not equals. So if this is false, right? Sorry, if this is true, because this is checking not equals, so a mod 2 is not 0, that means the number is false, right? I'm sorry, the number is odd, not false. Or you can do this, or you can do a mod 2 is 1. So that means the remainder is 1. So for example, if I do 3 mod 2, I should get 1. 5 mod 2 is 1, right? Because the remainder is 1. Because you have 5, try to divide that by 2, and 4 goes into that, you do 5 minus 4, it gives you 1. So that's just a quick summary for that.
One
Yeah.
thing, Kevin.
Yep.
Okay, first things first, someone just asked if they could get the CPP file that you're doing at the very end.
Oh yeah, for sure. Yeah.
And number
Absolutely.
2, I was thinking of another question to do.
Yeah.
For 111, my 111 exam a while back.
I think we should probably stick to these questions, honestly, because the
Okay.
students have probably been practicing these. And
Okay.
in case
I
they
was
do
just
refer
gonna
back
say
to
if
it.
we could
Yeah.
try something that
Yeah.
involves reversing a number,
Oh yeah. Oh yeah. I have an
because
example
that's a
for
very
that, but we can probably
possible.
find.
Yeah.
Yeah.
For instance, like
Um.
taking out a reversed number. I think that would be a good way of doing it because it would be involve returning something that isn't necessarily just a counter. So let's actually do that. Also, it goes through like kind of figuring out how to take apart a number and put it back together again.
Yeah. 1 second. Oh yeah. Let's just test this before we move on now.
Yeah, go ahead, go ahead.
Yeah, we're good. 2 and 5. Just give me one moment. Let me just read through these quickly.
Yeah, go ahead.
I mean, I think we should go over one that students have had the most trouble with. So by chance, is there anything that we can go over?
Yeah, is there a specific problem either from this sheet
This is also
or
an easy one here. Most of these recursion problems are going to use the same style. I think it looks like Professor Akinlar ordered these by heuristic, as in like the underlying method you're applying. Because I noticed that the first two we did basically have the same style, except you're just doing different conditions, a different number of parameters. So maybe if I keep going down, I should probably find something new. Let's see. I
yeah.
remember I saw a swap one.
I would definitely recommend
Big,
just
small,
practicing
price.
just practicing the way to do it. Like, honestly, if you understand the algorithm, then like you can be prepared for anything. Even if this was to switch the condition between odd and even to, hey, if it was all even, or if it was all odd, or if it, I don't know, the digits did something. I don't know. Like, you know how to do that part now, so you should be good.
Any other questions in the chat?
No, I don't see anything. Yeah, I just say whatever would be a good one to go over.
Hmm.
This would be
This
a
is
good one, number 11.
Yeah, this is actually a more tricky one, actually. Interlace.
Let's do that.
Right,
This one works.
recursion function called interlace digits. Yeah, it looks like you're mixing difference two. Let's see, 3, 1, 0, 7, 2. Interesting. So it takes in two integers, begins the first. Okay. There's a very cheesy way of doing this. You can use this using strings, but I'm not going to do that to myself. I'm actually going to discipline myself to go through this. All right. So it looks like I saw something pop up. How many questions are we going to have for exam? And can you explain each one of them, please? I don't know. I never took Professor Akinlar for 111. I took Professor Chin, so I'm not too sure how many questions you'll get.
Yeah, unless he gave like past
Yeah.
exams, which he doesn't usually do that. What I would
Yeah.
recommend thinking is it will likely be around the same length as your exam one. So, however long that would be, probably imagine it would be something along this. And I think knowing Akinlar, he'd probably take one question from each of those topics. That would be
Oh
my
yeah, for sure. That's my biggest recommendation.
four
I took
questions for
Professor
exam
Akinlar
one.
for 313 data structures, and he goes straight off the practice problem. So if you can do every single one of these problems, then you'll be good. But this is for recursion alone, so
Yeah, it's a lot,
yeah.
honestly. I wouldn't say do every single one, but just think
Yeah, I'd
how
say
you
just
do
try going through ones that have
different
uh
like
like different
algorithms to solve.
correct, like different way of approaching. All right, interlace digits. It takes two integers, right? So we have two positive integers, A and B. Okay. And we're going through each one, and here what we're doing is we are interlacing them. So this is the first digit, and this is going to be the digit that comes right after it. So we're going to append it. So this is interesting because here we're not actually appending strings. So a string you can just add together and then you'll create a bigger string. Here you're working with integers, right? So if you're to add them together, you're actually just going to get a different number. So if you wanted to actually interlace them, we would have to work with moduluses and divisions, right? So if I'm interlacing 1 and 2, then I would do 1 times 10 plus 2, and that gives me 12, right? So that's the number I want. Now, if I'm interlacing 1, 1, or 117 and 302, then I would need to deconstruct this somehow. So deconstruct this into 1 times 100 Actually, no. I mean, like just
What about
deconstruct
if
into
we
each
just
individual
do it
digit.
the same way that we did before, in the sense that we made a variable for each of the last digits, and actually wait,
Okay. So here we have 173,302, and we want to make sure that this first digit here is going to keep increasing. So that means we're starting off with the very first ones, right? Because if we begin with the last ones, I guess what we could try is take the last digits. We have 7 and 2, right? So that'd be 7 times 10 plus 2. And then we somehow curse this again. So the problem is from starting backwards. Let me just separate them here. If we start backwards, then I won't be able to add these guys. I would need to, because if I try multiplying this by 10, yeah, it'll be easier if I start from the beginning somehow. So theoretically, if I begin from the beginning, right, so I do 1 times 10 plus 3, right, that gives me 13, okay? And then now the next thing I can do is this times 10 plus the next set of digits, so 1 times 10 plus 3. Yeah. So that gives me 130. Well, I can't do this now, right? 130 plus 13. Let's see, times 10, that gives me 13 here. Start again.
I think we're gonna need to have in the recursive call, like have it divide by 10 each time, and then just kind of add together the digit 1 and then the digit 2. Like multiply that number by 10 and then add in the digit 1, digit 2, because when you're doing a recursive call, it's kind of working like backwards, right? It'll just kind of like it'll work from the inside, from the last inner call all the way to the outside. So if we were to divide it, divide it, then when it reaches the end, it works backwards and it adds together the innermost digit, which would be the left, then the first digit, then the second digit, then the third digit. So it's like it goes up a waterfall to chop off all the digits and then down the waterfall to add them back together, if that makes sense.
Right, but if we're adding them together, so you're insisting to start from the end, right? So 7, 2.
No. I'm insisting to, in the recursive call, we would call interlace digits of A divided by 10, B divided by
Mm-hmm.
10, and then plus we would take our number, let's say, like C, we can say, right?
Okay.
And we can say that C, we can multiply by 10 to give it that extra space, right? So if we have like a number that's like 1, which we could like start off with, let's say, and then we multiply that number by 10, right? So we get 1 times 10 is 10. Now I can add a digit to that if I say like 5 and I get 15. So that's how we can make sure that we can add together, we can add essentially insert these digits into our counter C, or like that final number C. So what we would do is on the outside of this, we would say whatever that number that we want to return, C, times 10 plus um, the A digit. Well, actually, wait, how would we? No, wait, then that would be the wrong digit then. Um, I think we'd have to do that then at the if statement. I'm not sure.
Okay, I think I got it. We have 1 and 17 and 302. We could start from the end, right? So we could do 72, right? And once we get that, and I'm just separate these real quick. Okay. We have 1 here, and the next one is 0, which is what I want. So I want to interlace these guys somehow. Oh, I see. I see what's going on. So let's look at it like this. So we have 7, 2, 1, 0, and then 1, 3. Right? Okay. We're always going to be accessing these last digits somehow. Okay, so this is 72. I leave it like that. And then this will be times 100. And this will be times 1,000. Because then this would be 1,300 plus. Wait, sorry. Do this correct. So 100,000. Wait 1 second. So this is the operation for times 10 times 100. Gives me 1,000. Yeah, because then this is going to be 1,072. Right. Okay, so this is what I have here. Yeah, so this is times 100. And this is times 1,000. Yeah, this is good. Sorry. Yeah, 13,000 plus 100. I mean, this is 1,000, but this will give me 14,000. I don't want that. Let's see. This is 13. This is 131,000. So then I would have to do 10,000 here then. Okay. So this is 100. This is 10,000. Next one is 100 times 10. Interesting. Okay, so this is what we can do then. Something of this sort. So that means if I'm doing interlace digits, I do A divide 10, B divide 10 plus, and this would be times 10 to the, well, I'll just leave it as 10 for now. Plus, I want, okay, I see. So I want the last digit. So I'll just do that. So I'll take my last digit int A last equals A mod 10. Int B last equals B mod 10. Okay. I'm gonna ignore this right now. And then this is gonna be plus, we'll do this times 10 for now. We have to change that. And then here I want this one to be first, right? So let's see, I have 1, 2, yeah. So this would be A last times 10 plus B last. Okay. Now the next one that comes after is going to need to be bigger. So maybe if we do 100. Yes, it'll be 100. Yeah, because look at this. So if we do this operation here, right? This gives me 72. I'll just ignore this. And upon the next recursion, right? I'm basically doing this plus 72, right? This is what's happening in this recursion here. So I do 10 times 100, okay? And upon the next one, this is 10,000, right? 10,000 is equal to 100 squared. So if this is the case, yeah, this is the same thing as saying 13 times 100 times 100 plus, well, I'm getting ahead of myself here. So times 100. Okay, so yeah, I should let me see how this would work here. So let's do 72 here. So this is interlaced digits. This, yeah, let me actually do a simple case here. So let's do 117. Let's just do 1 and 2 then. Let's see what this looks like. If I do 1 and 2, it's gonna do it by hand. So I do this. Here interlaced digits. Blah 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 blah. This is gonna just be 0 times 100 plus A last, which is 1 times 10. Oh, sorry. It should be 1 times 10 plus 2. And this is 0 plus 12, which is equal to 12. Beautiful. Now, if I do this one, 173 and 3 on 2, what I get here is I'm just going to call it f. This is the function. So this is going to be 11 and 302 times 100 plus a last times 10, which is 7 times 10 plus 2. So this is f11 30 times 100 plus 72. Now f11 30, this is going to be f13 times 100, right? Plus I have what did I say here? So 1130. This is going to be 1 excuse me. 1 times 10 plus 0, and this plus 72. Okay. Yeah. And this is multiplied by 100 as well. Right, Lauren, this is making sense to you?
Yeah, I see what you're doing.
Okay. So sorry, I was gonna write it like this again. F13 times 100 plus 72. Here's this real plus 100 times 100 plus 72. Yeah, plus 1 times 10 plus 0. Yeah, this is good. So now if I work this out in here, this is going to give me 1 3. Yeah, so this is going to be 72 plus this times 100, this times 100. So then on here I got the same thing. Okay, I got this. All right, and I got this times 1. This is going to just be 10. Okay, and I do this last operation here, right? So f13 is going to be equal to 1 times 10 plus 3. Yeah. And then that means I'm going to have 13 times 100, right? This gives me 1,300 plus 10. This is 1310. And this times 100 equals to 131000 plus 72 gives me 131072. And is that correct? Yeah, that's correct. Okay, perfect. So this is what the recursion looks like. So I apologize for just going through this whole on, but we'll go over it again. Just want to make sure that you guys understand it. So once I get it, then you guys will understand it afterwards. I promise. All right. So this is what the recursion is going to look like. So this is going to return 0 once we find out that so basically the same logic here, right? So once we've exhausted all the digits, then we can't check anything else, right? So, oh yeah, sorry, this should return interlaced digits. So before I move on and explain this, I just want to make sure this is correct. So let's do C out interlaced digits. Okay. Start with this case right here, the one I just did. All right, beautiful. So 131072. What just printed? What was that? Oh, it was this. All right. Let's see. Yeah, 131072. Yep. And let's check this one. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. All right, and then just for sanity check, let's check this very first one here. 1, 2. All right, perfect. So let's go over this. So this is a short and sweet function, but this is a bit of a complicated one, right? So what this is doing is it's reconstructing a number well, not really reconstructing one. It's just interlacing it. This is what the function is doing. So we start with the base case, right? The base case is checking, do we have any more digits to check, right? If a is less than 1, that means we're at 0, right? That means we've divided everything out to 0 in this case, right? So we have a divide 10, b divide 10. At some point, that just divides down to 0. So we just return 0. The reason we return 0 is because I'm doing an addition here. And we'll get to that in just a second. So int a last equals a mod 10. This is just acquiring that last digit of the number we're looking at, and then b last is acquiring the last digit of the integer b. Okay. So what this is doing over here is it's constructing a pair, right? So if I were to look at, for example, the number we just got, right? The two numbers, 173 and 302. Okay. So the last digits I have are 7 and 2. So if I reconstruct it into 72, what I would do is do 7 times 10 plus 2. Right, so it gives me 72. Okay. Now the reason I do this funky thing here, right, by multiplying by 100, is so that I can basically shift the next set of digits to the left. That's what I'm doing here. And so if I multiply it by 100, let's say I have the following number. I have the number 12, right? That comes in. And actually, let's do this. Let's just work with the numbers we got. So in the next operation, right, we got 1 and 0, right? So this is going to be 1 times 10 by the rules that we have plus 0, which is equal to 10, right? So now I have 10 and 72. And how would I like to append this? The way I do it is by shifting it 2 digits to the left, right? So if I multiply this by 100, I get 1,000, right? And if I add 72 to this, I get equals to 1072, right? So that's how I'm shifting it, right? I'm shifting it 2 digits to the left, basically, is what I'm doing. So I do the exact same thing again. So now I have 1,072. Yeah, and the next set of digits here are 1 and 3. So I do 1 times 10 plus 3, and that gives me 13. Right? And then what I do is I shift this by oh yeah, I see what I did. I see what I did here. I'm supposed to be shifting let's see, 100. This gives me 1,300. But then I have to shift it again. Okay. Yeah. So maybe I didn't actually showed the recursive flow correctly. All right, so let me actually do that real quick. Okay. So the whole idea is to shift digits to the left, but I want to make sure that I'm showing this correctly. So let's call it F, and we'll do a short one. Let's do F1112. Okay. So this is going to be equal to F11, right, times 100 plus 1 times 10 plus 2. Okay. So this is going to be shifting these digits to the left, basically, with this 100 multiplication, right? So then this is going to be equal to F11 times 100 plus 12, basically, yeah. And now what I would like to do is to compute this right here. This is recursion, right? So I'll compute F11. So F11 will be equal to, by the rule that we have here, right? So this is going to be F of 0, 0. And by the way, the way I got 1 and 1 is by dividing this by 10. So I divided 11 by 10 and 12 by 10, and I got 1 here. So if I divide 1 and 1 by 10 with integer division, I get F00. Okay. So this is going to be 1 plus 1 times 10 plus 1, right? So this is going to be equal to F00. And what is F00 equal to? It equals to 0. Right, because this is what the base case gives us. Plus 10, which is also equal to just 10, right? Because this is just 0 plus 10 equals 10. I'm sorry, I meant 11. because this is 10 times 1 plus 1. Yeah, 11. Okay. So that means F11 is equal to 11. And that means F1112 equals to 11 times 100 plus 12. And that gives us 1112. Otherwise, this is just going to be 1100 plus 12, which is equal to 1112, right? And that is how we interlaced the digits. Yeah. Any questions on this? All right, we're all good with this one?
Yeah, it seems that there's no questions in the chat. Would anyone like to continue with recursion questions, or is there another topic that you guys want to cover? I think we have about a half hour left. I mean, don't be shy, I know recursion is like a tricky topic. I think it's probably one of I think it's definitely the most difficult topic in 111. So, I think it just really comes down to like a lot of practice, practice a bunch of the algorithms and then you get it after a while. But yeah, if there's the other problems as well. Like there's one for program outputs I see, command line, program design, function. I mean, whatever you guys want to go over.
Will Raise be on the test?
I'm not sure, honestly. It doesn't seem to be one of the main topics, but it might be included. For instance, you could store things in an array. In fact, actually, if you wanted an easy-ish way of reversing digits that didn't have like a way of using recursion, let's say, you can kind of store all your digits into an array and then just reverse travel the array. You could do something like that.
I'm not able to open up the function signature for some reason.
Function signature one. Yeah, I'll take a look.
I can't open up command line arguments either. Strange.
Here, let me send it again.
Enable program design, I think has a
We could do a program design one if you want, or a function signature.
we have about well, we exactly have 36 minutes left, so we can go over quite a few of the function signatures if you guys want to. I guess we'll do array questions if that's possible, I guess.
I mean, I think this is pretty much the same as exam one stuff, I think. Like the best title lines.
Aside from okay. Let's do this. Let's do program design. I think function signatures
function
are a
title
little
lines are
easier.
yeah.
More challenging ones, like if you don't know how to do function signatures, that's okay. But I figure the programming ones are more important. And plus, like we're gonna get through function signatures like in program design. I think it's inherent to it anyway, so we'll cover it there. The programming ones obviously the ones you want to practice the most on, including recursions. All right, so I'll do 2 CPP files then. I'll rename them. So I just named it main just because it's a quick thing to name. So I'll separate them into recursion and program design to make things organized. But for now, I'll just separate it here. Let's do. So this is just remind myself it's a program design section. All right, Lauren, you want to read the first one?
Sure thing. Okay. Let me just open that part. So write a function called all_odd that returns a result of all odd if all the elements of a 2-dimensional array are odd and returns not all odd otherwise. This is kind of similar to the one we did before. I think it would be better to do a different one. Because it's quite literally the same exact thing. It's just we're just not doing it this recursive. We're doing an array.
Okay. Yeah. I think traversal across an array is still important.
Let's do 2. 2 is a better one to do.
Okay.
This one is still dealing with arrays, though. Write a function called increases that returns a result of true if the elements of an array increase as their index increases, and returns false otherwise. If the array contains 1, 3, 5, 6, your function should return true. But if the array contains 1, 3, 3, 5, your function should return false, because the element with index 2 is not bigger than the one with index 1. Okay. And it gives you also the program that can use it as well. So it says increases, right? If increases x comma 5. So this is this is actually gives us the hint for how we're going to write our function out. Since we know that because it's given an if, right? This means that it has to be either a true or false value. So it's going to return that value. A return value will be a Boolean. It also tells us what our parameters are, right? So x and 5. So 5 is just an int, right? X is an integer array. So from that, we're able to kind of decipher how we're going to need to write this function out. So this is also kind of helping you figure out title lines as well. Yeah.
So for the interest of time, I'll just go through it directly.
Yeah.
So this increases as if each subsequent digit is at least 1 apart, right? So if it's 3 and 3, they're 0 apart. So that means it's gonna return false there. So since this is returning a Boolean, right, we're gonna have a bool as return value because this is if true, if false, right? It's not if 1. Well, if 1 would be true because 1 technically is true. But if it's a Boolean, then you can use it in a condition like this. So Boolean increases, we're going to call it. So what's it called right here? Increase. And it takes in 2 parameters. It takes in an array, x, and some integer. Integer is the size, right? Yeah. Okay. So we're going to have int x, and we're going to have these brackets right here. So this denotes an array. This is a 1-dimensional array. So this is going to be an open close bracket. And you're going to have to specify what type of data type it's going to be containing. And the next one's the size. So int size. And the way I know it's size is because here I look at this this line right here. So it takes in first the array, and then it takes in this number, and that matches the number of digits here. Or sorry, the number of integers contained. I think it also specifies it here. I didn't actually see it. No. Yeah, but I think that's just the size. Because you can't, I mean, you can access the size within your function, so you can use a special trick to get the size of the array. But to make matters more simpler, you just hard code it. Okay. So we're going to be using a for loop to go through the array. So we're going to start by initializing integer I equal to 0. So that's the beginning of our iteration, excuse me. And we're going to do this so long as I is less than the size, and we will increment this by 1, right? So you can think of this as sort of satisfying this condition. So you start at 0, and so long as this condition is satisfied, as in I is less than the size, then you increment I. So the last iteration of this would be when I is equal to the size. So once I equals size, then you stop, right? Which means whatever's underneath here, right, inside these brackets will not run, will not execute. So more specifically, it stops at I equals size, but the last operation it executes is size minus 1, right? So if you're doing, for example, size equals 6, that means it'll increment from 0 to 5, right? So it'll run for those operations. Okay, so now we want to check if it's increasing. So since it's a linear check, we're just checking subsequent slots, right? So I'm checking, so here I'll just check int, or I can do this actually. I can do if x of I, right, is less than x of I plus 1. And then we can continue. Or what we can do actually is if this is greater than or equal to x of I plus 1, right? Then this should return false. Okay, otherwise it returns true. Okay, so this is basically the negation of less than. So for example, if I had this, I'll just write it up here. By negation, I mean like if you were to sort of do the opposite of it, right? So by negating it, I mean like doing the this operation, the exclamation mark, right? And then this would be equal to this. So it'll be greater than or equal to. Because if you're negating something less than something else, then the opposite of that would be that it's greater than or equal to it. So this is why I have this operation. But the problem is here, you might actually run into indexing issues, or more specifically out of bounds issues. So what could I do? I can just subtract the incrementing, or the iteration size in this case, right? So I subtract 1. So now if the size, for example, were 5, right? So size equals 5. And I'm doing this loop here. This will iterate from 0 to 4 initially, right? If I didn't have minus 1. But since I have minus 1, right, this would be from 0 to 3. Because now I can do the following checks. I can do the checks between x of 0 and x of 1, x of 1 and x of 2. And I can do x of 2 and x of 3 without needing to worry about getting into out of bounds issues. Because if I was doing it from 0 to 4, then the loop will also check this. However, this is invalid. Sorry, let's do 4. Actually, no. Let's do this. X of 4, x of 5. Yeah, sorry. Yeah. So if I were to do it up to here, right? Because this is if, for example, if you're doing this, but it's not subtracted by 1 as its size, then your loop will also check this, right? Because I is 4, because that's the last index before you're out of bounds, so you're going from 0 to 4. If you check 5, that's gonna be the case because you're doing I plus 1, so 4 plus 1 is 5. Then you're gonna get an error because this is out of bounds, right? Because your indexes, or the indices are gonna start from 0 and end at 1 minus the size, or size minus 1. So that's why we have the size minus 1 here, to make sure that it doesn't go out of bounds. Okay. So yeah, otherwise, if none of these checks here are true, that means it is in fact decreasing, right? So if it goes through the entire array without ever returning this, then that means it's returning true, right? Because that means it's actually increasing. Okay, so let's check this. I'm gonna copy and paste this. Yeah, it increases. But if I put 3 here, it does not increase. Okay. Yeah. So this is a very succinct way of actually writing it. So I'll actually comment the details, specify what's going on. So increment 0 and size is 1. We are Lauren, you can pick the next one,
Sure thing.
unless someone has a specific one in mind.
Yeah, again, like if you guys have one that you want to go over, by all means, but otherwise I'm just gonna pick another one that might have a different strategy that we can try to do.
We are going to get the video access, right? Later on. The
Yeah.
recorded one? Okay.
Yes.
I'll use that word. Be increasing.
Yeah, sorry, just still looking.
No, thinking about it. How can I guess at the end I can just send this file to the chat and people can take it, or is there another way that we can do it?
Yeah, I would just say put it in the chat at the end.
Okay.
Yeah, I
I'll
could
do it
also,
like once we're at like 5:55 or something like that.
sure. Okay, what about 28?
Yeah, that's pi 3141592 It's funny. Write a function called largest gap that returns the largest gap between two adjacent elements of an array. Okay, we can do that. That's a good one. This is fun. Another linear iteration, but this is actually keeping track of maxes across. So this is a good exercise, actually. This is a very good one. All right. 1 second. Let me just are there any questions on increases by chance?
It does not seem to be like any in the chat right now, so I'd say just let's keep going. I think we have time for maybe 2, 3 more, I think. So
Sure. You can see I really like my comments because I want to make sure people understand each thing. All right. So let's look at this one, right? Largest gap. So print 7 is the largest gap between 9 and 2. Actually, I have to specify, is this absolute value or is it just positive? Let's see. I think it's absolute value, right?
Yeah, if it's talking about gap, then it would be absolute value because
The
it's always gonna be
distance.
positive. Yeah, you can't say that there's like -5 away from it, you know. So yeah, definitely do absolute value.
Okay, so they're adjacent elements. Got you.
Yeah, so this would mean that okay, I have to check
7.
3 and 1, the distance between the gap. Oh my gosh, sorry. Yeah, the difference between those two, then 1 and 4,
Yeah,
take the
yeah, yeah.
difference between those two, 4 and 1, on and on and on. I'm assuming it's not circular, so I wouldn't have to check the first and the last, right?
That's a good point, actually. It's a lot of questions that arise from this problem. So let me just
I'm gonna say no
voice that.
because it's technically not adjacent.
Yeah, yeah. Correct, correct. So let me voice a couple of things. So when we talk about distances, you're going to be using the absolute value function in C++. It's quite simple. It's just ABS, or I guess since I'm using namespace std, if you weren't using this, I think you would need to do std absolute value. Yeah, you would need to do that. But always make sure to just use this because you can just avoid using that that line. Okay. So that's what distances mean. You're going to be checking the absolute value between elements. And since they're adjacent, we're basically going to be doing the same type of iteration. We go from 0 to size -1 to avoid the legal index axis exceptions. Because if we're doing size -1, I can do comparisons between 3 and 1, 1, 4, 4, 1, 1, 5, 5, 9, 9, 2, 2, 6. But since in the code I'm doing the checks between subsequent the current and the subsequent value, if I were to increment until size, until 1 less than the size, because that's how the iteration is going to work, right? I'm at 6, and there's nothing that comes after 6, right? It's going to access some illegal spot, so it's not going to work. Otherwise, if it's size -1, it'll just do 3, 1, 1, 4, 4, 1, 1, 5, 5, 9, 9, 2, 2, 6, and it ends there, right? So it does not do the check at 6, because otherwise we're going to access nothing. So we're going to be doing the exact same iteration as I said. So we're going to do largest gap. So we're returning an integer, so largest gap. Let's do int x. Again, we're just getting ourselves some parameters. We got 8, which is the size. Okay. And we're going to initialize or solve distance. So int distance. This is going to be from I = 0 to I less than size -1. Okay. And we're just going to be checking what the maximum distance is, right? So I'm gonna call this max distance. I'm gonna camel case this too. And I will set max distance equal to the maximum of max dist. And why can't I? Oh, I guess I have to finish this then right here, right? So x sub I minus x sub I plus 1. And then I'm going to take the absolute value of this, right? And then I'll return max distance. So let me explain what's going on here. So max distance is going to be the max. So the max function just takes the maximum between 2 integers, right? So it'll check the max distance between, it'll check the max between max distance and this expression right here. So absolute value of x sub I minus x sub I plus 1. So all it's doing is checking the distance between adjacent values, right? So This does begin at 0, right? So upon the next iteration, right, the max distance is going to be this, right? It's not going to be this anymore. It's not going to be 0. So since max distance has been assigned to the next larger value, right? You're going to be doing max distance, so that's going to be the current maximum, and you're comparing that with the next check, right? So if I do the comparison between, let's say, max distance 0 and 3 minus 1 is 2, I have 0 and 2. So that means now I'm checking 2 against other distances. And this is a nice succinct way of writing that, right? So if I were to run this, I'm sure, let's see, I get 7. Yeah, output is 7. So we're good. Any questions on that? It's always important to know use the absolute value function, because I think if we didn't use the absolute value function, we'd still get 7. But this ensures that we're taking the largest gap, because gaps or distances are always positive, right? They're not going to be negative. It doesn't make sense to take a negative distance unless you're involving direction, I guess. Yeah. I guess we can move on to another one then, right?
Yeah, we could do one more. Let's do 69. It calculates the
Wait,
okay,
which
so
one's 69?
yeah, write a complete C++ program that does the following. It asks the user to enter a 5-digit number n. The program reads the value entered by the user. If the value is not in the range, the program should terminate. The program calculates and stores the 5 individual digits of n, and it outputs a barcode made of 5 lines of stars that represent the digits of the number n. So it's like if you have a number like 163, you're gonna have 1 star, 6 stars, and then 3 stars again. Oh, it's on page 20.
Oh, yeah, so I was just getting the question number for the last one. I can write it. I can refer to it. Q. Okay. Question 69. All right. All right. Write a complete C++ program. This is following. You read it. All right. So interesting. So this time we're actually taking in input. It reads a value entered by the user. If the value is not in the right range, the program should terminate. So I guess if the number is greater than 10,000, or sorry, greater than 1,000, the program calculates and stores to 5 or 10,000. Sorry, calculates the stores to 5 digits of n. Outputs a barcode made of 5 lines, starts for digits. For example, the following business evaluation. Number 1, 3, 6, 3, 8, 4. Okay. Nice. All right. We can do this one pretty quickly. So we will do I'll do a void because it's not returning anything. This is returning. It's not returning. This is outputting the string here. So void. What is this going to be called?
I don't think it, yeah, I think, yeah, it doesn't really give a name for it. That's fine.
So we will do cn. Cn goes this way. Yeah.
Yeah.
Cn integer input. Just to initialize it to 0. Input. And it terminates if the user gives the wrong value. What's going on here? Oh. Cout. Enter. integer value. Okay. Okay, so here we ask for the input and we check if it's in the range. So if the input is greater than 10,000. So this is if it's more than 5 digits. Or it's less than 10,000, so it's less than 5 digits. Or we could just do this. So if input is not equal to 10,000. No, let's not do that. Let's do.
Oh, wait,
Let's do
it's just supposed to be
yeah,
a
yeah,
five
sorry.
digit. Yeah.
Yeah, so if it's less than 10,000 or input is interpreting this correctly.
Yeah, so
Yeah,
it just has to
if
be
it's
a-
less than 10,000, if it's greater than 10,000. Because it's not within the range. Because 10,000 is within the range. So if it's less than
Oh,
it or if
wouldn't
it's
it
greater
be
than it,
wait, no, it shouldn't it be like like 99999 because it's supposed to be 5
right.
digits.
Oh yeah, so for this one, so if input's greater than this. I'll
Yeah, it would just
say
be
greater than or equal to 100,000 then.
yeah, that works too.
Yeah. This is 1, 2, 3, 4, 5, 6. Yeah.
Yeah.
Then we
Okay.
terminate, so we just return. We do nothing. And returning in a void, like typically, I mean, you were told that you return nothing in voids. But just writing this just terminates the program. All right. The programming calculates and stores the 500. We don't need to do this step right here. That's unnecessary. We can just do this instead. So we can do for I equals 0. We're incrementing since the number we're given is 5 digits, we're going to do this operation, the barcode thing, 5 times. So we're doing I less than 5, 5 plus plus, and then we do those 16384. I see. So we are going to need to store this then.
Yeah, because wouldn't we need to
Okay.
keep track to be able to know
Yeah,
how
yeah,
many
yeah, yeah.
times to loop through it for the stars?
Well, this is what we could do. We can establish an array size 5. And what we can do is we can do a for loop here. Store each individual digit. So x sub I equals to input mod 10, and then we just take off the digits. So input equals to 10. Now, yes, I'm aware that this is getting the last digit, but what I can do instead is just increment this backwards. So I can start this from 5, and I can do greater than or equal to 0. And instead, I could just decrement.
Yeah, so again, just to kind of clarify the reason for that, right? When we go backwards, right? We go from the right to the left. Now, when we want to get it in the correct order because it's in an array, we can just like go from the back of the array to the front. So that
Yeah.
works too.
Okay. This is not really gonna be an efficient algorithm, but let's just do this anyway. So int k equals to k less than of x sub j, k plus, this be c out star. Okay, and then at this line, we're just going to print the line. So basically, this is going to go through the array. So this captures every digit starting from the very end, but now we're incrementing backwards. So this will basically start from the beginning of the digit of the number, right? So what this will do is it'll increment the number associated to the position of the array. So this would be x sub j. So the very first one, if we were to look at, let's say 16384. What this would be then, right? This would be 1. So x sub j would be 1. And then x sub j plus our j minus 1 would be 6. Right, so you're beginning at j equals 5. So at j5, I'm sorry, there should be 4. Because we're doing yeah, so this is of size 5 with the index is at 4. Yeah. Okay. Yeah. So what this does is store the digits into the array. Backwards. And then increment, or I guess starting most position. And then this is increment through or iterate through the container backwards, parentheses to get the correct order of the number. Okay. This is the outer loop. So that's for the outer loop. Now for the inner loop, each x sub j will determine how many stars to sequentially. Okay. So for example, x sub j would be, where's my number? Here. This would be 1, and then this would be 6, and then we have 3, and we have 8, and then we have 4. Right. So initially, the way we stored these numbers was like this. So we stored it like this. So we stored it as 4, 8, 3, 6, 1. And the reason we stored it like this is because of this set of operations right here. Right. Because here I'm just trying to just capture digits. Right. So I'm storing the number backwards. And since I did that, how would I like to, get back those numbers in the order that I want them? Well, then I just increment or iterate starting from the end. So I increment starting from here, and then I keep going until I reach the very first digit here, or 0 in this case. And this is being done through an array. So each digit here is given an address. So this would be 0, 1, 2, 3, 4. Right. So here I start from 4 and I end at 0. Right. So the first one prints out a single star. Upon the next iteration, I get 6 stars, 3 stars, 8 stars, 4 stars. All right, so let's see this in action.
Also, since we're nearing the end of the session, if you could just fill out this feedback form when you get the chance, that just kind of helps us to know how we can improve for the next sessions.
Yeah.
So yeah, I just put that in the chat.
Cool. So we enter the same number here: 1, 6, 3, 8, 4. I get 1, and I should get exactly what I got here. So yeah, and that's
Yep.
it.
You're good.
All right, I'm gonna split these up. The meeting doesn't just come to an end like immediately, right? It's just
No, I mean it's 6 o'clock now, so I think we should be
all right,
fine.
so if you guys could stick around just for a little bit so I can give you the files. It shouldn't take that long.
You could just keep it like it's all in one. Make it easy.
Okay. Yeah.
That way people don't have to download like multiple files and stuff.
Sure. Yeah. Organize these then.
Yeah, go ahead. In the meantime, if you guys could just fill out the feedback form. Okay, and are there any final questions, whether about the exam, the class, anything that you guys? All the exam topics? Okay, so, those reviews that he gave, those files, I'm going to bet there will be one question from each of those. So these were the program design questions. There's probably going to be one of those. There's probably going to be a recursion question. There's probably going to be a command line question. Whatever he's done from the time of the first exam until now will likely be what will be on this exam. So honestly, I mean, it's impossible to do all the questions, but kind of be smart about it. If you've seen one that has pretty much the exact same algorithm that you've done before and you feel good about it, then just don't do that one yet. Otherwise, you can always practice like different questions and everything. So that's what I would really recommend to do for that. And also, you can use AI to kind of generate more examples if you want as well, but I think you kind of have a lot there. You could even probably put in those examples and say, hey, what would be some good ones to go over, to kind of help you decide, which ones to do. So, otherwise though, like, yeah, just honestly, if you feel good about those topics that like he posted, then you should be totally fine for that. So, yeah, just spend the weekend practicing. Yeah, of course,
I'm
we're
putting
happy.
the thing in the chat now.
Okay, perfect. Oh, look at that. Got this from the lab PowerPoint. Exam 2, 4 to 6 problems. Okay, that's pretty much what we assumed. Provide function signatures, title lines, program output, recursive functions, write a complete program and or a function related to
Do I
array.
just sorry, I didn't mean to interrupt, but do I just drag and drop? Is that what I
Yeah,
do?
try that. If it doesn't work, you might have to save it as a TXT file.
Oh, that's very unfortunate.
I mean, people could just convert it and put it into their
How do I
program.
get I have an emoji table thing on the. Right, that
But
was weird.
yeah, honestly, that seems to be pretty much then exactly what I was thinking. Honestly, it's just practice each of these. Maybe you think that title lines are easy, or maybe you think program output is hard, or something along those lines. Whatever you find that you need the most help with, just keep practicing that. So he pretty much
I have an
gave you
idea.
everything
I'm
that
gonna
could be.
go my replit real quick.
Oh, that's a good idea. Give a replit link. That works too. Okay. I'm going to actually stop the recording here. That way it could start uploading.